Second example is going to kind of work with the radius formula and the actual size of the orbits Bohr quantized, or basically the size of the orbit Bohr said that the electron would exist within. And this is going to use the radius formula. And again, like I said with example 1, this would be something that would have to be given to you. So when we're talking about closer, we're referring to distance between these two energy levels. So you would end up having to use this Rn equals R1 times n squared formula. And Bohr worked out what the first orbit was, 5.29 times 10 to the negative 11 meters in size. So what we want to do is it'll say how much closer will an electron be to the nucleus when it moves from energy level 5 to energy level 2. So energy 5 to energy 2. What we're doing is if we found the radius of the fifth orbital, we would know how far it started, or what distance it started from the nucleus. If we found the orbit of the second orbital, we would then know the radius of orbit 2. And if we want to find out how much closer it came, we would want to know the difference between these distances. So what I'm going to do is I'm going to write one single formula. The distance here is going to be R5 minus R2. That's going to tell us how much closer we moved. So the formula will then be equal to R1 times 5 squared minus R1 times 2 squared. We can put the value for R1 in, even factor it out if you want. You could simplify this many different ways, but again, I haven't been dealing with a lot of factoring and a lot of the math concepts. We'll just kind of get used to just substitution and going from there. This is going to be 25 times 5.29 times 10 to the negative 11 meters minus 4 times 5.29 times 10 to the negative 11 meters. If you punch that in on your calculator, 25 times 5.29 to the exponent negative 11, subtract 4 times 5.29 to the exponent negative 11, you should get 1.11, I guess, times 10 to the negative 9 meters. So this question is involving the distance between those radii, and you'll see in the little diagram in your notes, I kind of give you a relationship how these radii are related to each other. They're a squared ratio. It's not linear. So as soon as you go from orbit 2 to 3, it becomes significantly bigger. Not just 1 time bigger or 2 times bigger. It's a squared ratio. So you jump a couple orbits, that's a large distance according to the size of an atom. Anyway. So again, just to kind of mention this one more time, when you're dealing with the Bohr formulas or you're asked to deal with Bohr formulas on a diploma exam, formulas will be provided. On my exam, since you're allowed to have open book, keep these with you for the multiple choice numeric response section, and obviously you can always refer back to your notes to help you with the written response.